Right, today we start the paper 3 for further mathematics. So paper 3 will be further mechanics. So for paper 3 and paper 4, each paper will be 1 hour and 30 minutes. Right. The contribution of the marks for this paper, each paper, right? Paper 3, paper 4 also 1 hour 30 minutes, and each paper contribute 50 marks, raw marks, right? So paper 3 will be further mechanics, paper 4 will be further probability and statistics. So paper 3 actually this is a compulsory paper, so you cannot escape, not like the mathematics last time. Paper 4 you can escape and you just take the paper 6 for your final exam. So for this time, you need to go to the exam for paper 3 and paper 4 also. So in the further mathematics, 4 paper are compulsory paper, paper 1, 2, 3, 4. So further pure max 1 and pure max 2 should be will be under Royal. So 3 and 4 application will be under me. So uh, for further mechanics, actually all the skill you should relate to the skill that you have learned before in the mechanics. In these chapters, not chapter, in this further mechanics, still the same things. You need to use some logical thinking, and the calculation is not complicated, but the logic and you must understand. All right, if you don't understand the logic, it will difficult to calculate. All right, so go through this further mechanics. We have few major chapters. So chapter one will be projectile motion. Chapter 1 will be projectile motion. Chapter 2 will be equilibrium of rigid body, right? So will be center of mass and moment. Chapter 3 will be circular motion, the motion in a circle, okay? In a circular, you will talk about angular speed, omega, right? And chapter 4 will be Hooke's law. Hooke's law will be something like talk about last time when in the mechanics we always consider, the string is in the rigid body. The string is cannot deform. But in further mechanics we will we will assume that sorry, no, not assume, under Hooke's law the string or the wire can be extended, right? Right, can be extend or can be compressed, but we will not consider the deform or the shape of the item. We just consider it can be extend, it can be uh, compressed. Chapter 5 will be linear motion under variable force. This chapter is similar to the paper 4, but they will involve partial fraction and some integration and differentiation that you have learned in mathematics paper 3. And chapter 6 will be momentum. Momentum you have learned in paper 4 also, but this momentum will be a little bit different. Mainly will be linked to the loss of energy, and also will be have the oblique collision. Oblique collision mean is not the collision in the same line of center mass. Will be maybe the collision will be involved in a different angle, like a snooker box, a snooker ball, right? The snooker when you hit in a different angle, when you hit, right, they will have a different output. Okay, so the major chapter will be 1 to 6. The chapter is not so difficult, but you need to have some logical thinking about that, right? So actually, this paper 3 will be for next semester. We start a bit first. The content is not so much but we will focus on calculation basic. Alright, okay, so today we will start projectile motion. So projectile motion will be the chapter 1, and in the projectile motion, when we talk about projectile, usually this means the projectile is launched at an angle. What is the meaning for angle? So let's say this is an item, this is a particle, we still consider a particle. When we talk about projectile motion, we will launch with a certain angle, theta, right? And you will have an initial speed u, right? So when we talk about this is a projectile, most probably this item will move in a parabola shape of a motion, right? So maybe you can say it's a quadratic motion. Some book or in your formula booklet, they will mention the motion is in the trajectory motion, so they are same. Okay, so and in this situation, this is because the horizontal motion is depends on only the t, while the vertical motion is dependent on the t square, right? So you have a motion in the parabolic direction, right? So in this projectile motion, actually you just have this very basic concept: move in an angle with an initial velocity, okay, u, and it will move in like a parabolic. Okay, so I think for the physics student, you may have not any problem on this question. Should be like, I think it's quite so, I mean, quite easy for you. But when we do this projectile motion, you need to have some assumption about that. Okay, what kind of assumption that you need to involve? Sorry. Okay, what assumption that you need to involve? The assumption that you need to involve will be this motion will be in a 2D. Right, this motion is 2D. We just consider 2D. So mean you only have x and y. Okay, x will be the horizontal motion and vertical motion and for the y. And this projectile motion, normally we will ignore air resistance. Okay, we will ignore air resistance. And also, for this projectile motion, the g is constant, right? So normally, for an item, you travel from one point to one point, we assume that from A to B, along the way, the gravity is constant. And last one, the item fly projectile with a no spinning, right? So means when you project the item, the object like fly like will be fly like a aeroplane, right? No spinning. I mean the thing will be not rotating. Okay, so these are the assumptions that you need to use in order to do the projectile motion. So this is assumption. The question may ask you, so normally this kind of question maybe 1 or 2 marks. It depends on the question. If you see the question 1 mark, you give an assumption, then maybe you give 2. Okay, if 2 marks, maybe you give 3 for a safer, I mean, situation. And now we go for the basic calculation for the projectile motion. Okay, so we proceed to the projectile motion. Just now, as he say, when you have an item projectile with you and you have a theta here, okay, so you will have 2 components of velocity at the initial situation. Okay, at the initial condition, the vertical uy will be equal to u sine theta, right? And the horizontal component of the velocity ux will be equal to u cos theta. Okay, so when you have these two situations, you will you may consider the velocity, not velocity, you may consider the scenario become a vertical or horizontal component. So this one we can separate them into two components. Okay, so now we look at each component. Right, so for horizontal component, means when the item fly like that, projectile, you have a horizontal component of u. Okay, so in the horizontal component, because we assume that just acceleration that act on the body is a gravity. So the gravity is at the vertical component. So when we talk about horizontal component, we don't need to consider any acceleration that act on the body. So we can say the acceleration for horizontal component is 0. So ax is 0. So when a is 0, means this is a constant. No any component that no any factors that affect the velocity. So means at the horizontal component, we can consider the Vx is equal to u cos theta all the way. U cos theta all the way. Right. So means the velocity won't change all the way for the horizontal component. So if this is a constant speed or constant velocity question, what formula you're going to use? You will use the constant velocity formula. The formula is v equal to st, right? Or maybe we use the horizontal distance or range, we call x over t. Okay, so means if you want to find the horizontal distance that travel, x will be equal to u cos theta t. Right, so this is for the horizontal component of the item. Okay, so now we settle the horizontal component. Now we go to the vertical component of the item. So for vertical component, same things, the thing projectile like that. Oh, already the bend. Okay, no issue. Okay, so vertical component will be uy horizontal. So theta here. So now, don't forget, you have an acceleration at the vertical component. So if you take the initial situation as a reference point, the gravity will be, if you projectile upwards, right, the gravity will be equal to negative g. Right, don't forget the g is equal to 10, right? G equal to 10. So all the way is 10 from mechanics before until now also G equal to 10. Okay, so actually this is a deceleration, right? So for the acceleration at the vertical component is negative G, right? So and we have assumed that all the way this is a constant acceleration movement or motion. So when you have a constant acceleration motion, you can apply all the formula from the constant acceleration formula. Okay, so the formula is inside your formula booklet. You can have a look. So if we want to find the velocity at certain time, Vy, the vertical component of velocity, we can use u plus at, right? U plus at, right? Okay, the u is u sine theta just now. Okay, this is a general one, general one. U plus at is a general one. So now we put in the component. So will be u sine theta. G is a is negative g, and we put a t. Right. So this is the velocity at a certain particular moment. Okay, after launching. So this is the vertical component of velocity. So how about the height that you want to find? If you want to find the y, I mean the height that the item travel. Okay, so what formula you need to use? Same things, you can use the ut plus half at squared. So if you want to put all the items inside ut plus half at squared, so you can say ut is u sine theta ut, then minus half a is g and t square, g t square. Okay, so your vertical distance, the displacement that travel is u sine theta t minus half g t squared, right? So the way to derive the formula from the basic information that you have. So I have listed the formula that you have that you need in the table. Okay, so maybe you can reference to the notes. Okay, I will upload there. And so this is the thing that you need to know for the situation. I think should be okay, right? So you just remember, for the horizontal movement is a constant speed motion. For the vertical component of motion is a constant acceleration motion. So you no need to memorize this formula. So in your mind, you know which one is constant speed, which one is constant acceleration. You were able to derive immediately. Okay, you no need to memorize this one for your reference purpose only. Okay, so right, now we can move to example 1. Okay, for example 1, as part of a science experiment, a ball is projected into an A at 20 meters per second at an angle of 40 degrees above the horizontal. Okay, you must sometimes you must be careful because the question give you the angle above the horizontal. So above the horizontal mean you projectile in this situation 20, then 40, right, above the horizontal. So let's say the question say the item projectile, okay, below the vertical 40 degrees, then will be another side already. So you must be careful about this. So the angle, if they say above the horizontal, will be 40 degrees from the horizontal. Okay, so below the vertical mean another side already. So you must read the question properly, don't put the angle wrongly, right? So, and A, how long does it take for the ball to reach to the maximum height? Okay, so how you're going to calculate the maximum height? So at the maximum height, the velocity equal to, at the maximum height, the vertical velocity equal to 0. Right, so we put the initial condition, but if you don't want, you can directly calculate, it's not an issue. Okay, so we know that u equal to 20, theta equal to 40, and v maximum is 0, and g is equal to 10. You know that. So question is how long it take for the ball to reach to the maximum height. So how long mean what is the time that you need to use. So you can say v, okay, because 0, u is 20 sine theta, okay, minus 10t. Right, this formula from the previously. So if you don't want to use the formula that from this derived formula, you can directly use the constant acceleration formula and put in the values. You should able to find the value. So then you should calculate this, and you should get the t equals to 1.29 second for part 1. Okay, for part B. For part B, what is the maximum height of the ball? So just now you have calculated the t. If you can try to put in the exact value, because 1.29 is a round-off value in three significant figures. So if you can, you put in exact value. You cannot, you may put in longer significant figure, right? So let's say t equals to 1.286 second, and you know u equal to 20, theta 40, g equal to 10, t equal to 1.286. Okay, so in this situation, you want to find the maximum height, mean you can directly put the y formula. U is 20, 20 sine 40, 1.286 minus half g t square, right? Okay, so all the material is just put inside, so you should able to get the maximum height is equal to 8.26 meter. So the basic formula that you need to use. So as I say, you don't need to memorize the formula. If you cannot memorize, you just derive from the beginning. You just take the original acceleration formula and put in all the velocity and t and the angle. You should able to find the answer. Okay, so this one for question B. For question C, question C, what is the range of the ball? Range means the total horizontal distance that travel. Okay, so from the starting point to the end point. Okay, so as you know that this is a projectile motion like that. So what is the similar situation if you want to find the distance from here to here? This is the range. This is the range. If you want to find the distance here, you should find when the item reach at this point, the end point, right? When. So if you want to know how you're going to find that, because at the beginning and at the end, if this is a semicircle projectile motion, you know that at the end, the vertical distance, vertical height that the at the end also equal to 0, at the beginning also equal to 0, mean the y. So if you want to find that, you need to use the basic formula that for the y in order to find the time that at the endpoint. So that use the time that at the endpoint, then put in the constant speed formula, you were able to find the range, right? So now we try to find. So now we use the vertical distance is equal to 0, y, and we have 20 sine 40 t minus half a t square, right? The vertical component is 0. So simplify this, you should able to get t square minus 40 sine 40 equal to 0. And factorize this, you may get t equal to 0 or t equal to 4 sine 40. Right, so t equal to 0 means at the beginning point. Mean another point will be the end point already, t equal to 4 sine 40. So once you have this t equal to 4 sine 40, you may put inside the x equation. Right. So the x equation that given the range, x is the range, is equal to u t cos. X is the horizontal distance. So if you want to find range, mean the maximum horizontal distance. Okay. So u t cos theta, u is 20. T just now is 4 sine 40. And cos 40. So once you put inside, you should able to find x equal to 39.4 meter. So this is the range. Okay, so this is the range, the maximum horizontal distance that travel for the item. If this projectile motion is direct reach on the ground, so the item should be stopped at the ground. Okay, we assume that, but not always the reference line is at the ground level. If the reference line is higher, okay, your item after this point may continue to travel down. Okay, so in this situation you need to consider further what is the traveling point. So that kind of question you need to analyze further. Means if this is a projectile motion, okay, from starting point to the end point, okay, normally we consider this item wouldn't cut through the x-axis, but if this item cut through the x-axis and go further down, then your range will be different story already. You need to consider all the distance that below the x-axis also. So at that point we will see what kind of question that we have lah, then we discuss again. Okay, so now we proceed to the question 2. Okay, why question 2, sorry. Before question 2, I need to ask you why do you think that why is the velocity is 0 at the maximum point? Right, actually the vertical velocity at the is 0 at the maximum point because this is a projectile motion and this is projectile motion, and don't forget at the maximum point is a turning point. When at the turning point, what happened? At the turning point, the velocity is reached to the maximum and stop a very short moment, and the item will start to change direction. So at the maximum point is the turning point. Okay, at the turning point, velocity will be equal to 0. So the vertical velocity at 0, but don't forget the horizontal velocity is still moving. Right. So last time in the mechanics we just go up and go down. So you still remember go up and go down. Now you have an additional horizontal velocity, so the item will move like a projectile, right? Move with like a curve. Okay, so this is the reason. It's a turning point. So you have a instantaneous stop at the top and change direction, so that the vertical velocity at the maximum height is 0. Okay, so example 2, the batter hits a baseball at 53.9 meter per second at an angle of 60 above the horizontal. It is assumed that the baseball is hit from the ground level and move freely under the gravity. Okay, so from the ground level we should be safe. Okay, so A, the horizontal distance traveled by the baseball after 6 seconds. So same things, this is the projectile motion. Just draw a simple one. So you have a starting 53.9 above the horizontal 60, right? So you have a ux, ux is 53 cos theta, uy will be 53 sine theta. Okay, you have two components, right? So now question asks you find the horizontal distance traveled by the ball after 6 seconds, right? So it's a you need to use the ux. So horizontal is x will be equal to 53 cos 60 times 6, right? Question 1. So this is the very simple. So when you calculate, this one should be equal to 162 meter, the horizontal distance that travel after 6 seconds. Okay, and now go to part B. Part B, the vertical displacement of the ball after 6 seconds. So for the vertical will be the y. Y will be equal to ut. U will be equal to 50 sine 60. T will be 6 minus half a 10. So if you worry about the positive negative, this one you can, here you can keep at positive first, then here the G here you put negative 10 also can, no issue. Okay, so that you know is a deceleration, and times the t square. So you should get the vertical displacement is 100 meter after 6 seconds. C, the speed of the baseball after 6 seconds. Okay, this question, they mention about the speed. They never mention is vertical or horizontal. So mean is the resultant speed. Okay, is a resultant. So when this is a resultant, you need to consider vertical and horizontal component together, right? So now we start to calculate for question C. For question C, you know that the horizontal component won't change. So the horizontal component will be same to 53.9 cos 60. This one won't change. We assume that this one will be maintained because no any acceleration or any external force act on the body at the horizontal direction. Right. So you can keep this one as a don't simplify it because this one look like it's not an exact value. How about Vy? Vy you can use the formula that at the beginning U 53.9 U sine U plus 80 plus 80, A will be negative 10 and T6 okay. So this is the formula that you need. Okay, you will get a acceleration. Sorry, you will get a velocity. So this velocity for Vy maybe is a negative, but no issue. And you know that the speed that you need to find is equal to Vx squared plus Vy squared. So you need the resultant when the question asks like that. So you put the values inside directly, don't round off, and you should get the speed at the particular moment is the speed will be equal to 31. Okay, so 30.1 meter per second. Right. D, the direction in which the baseball traveling after 6 seconds. Okay, so just now if you already know just now if you calculate the Vx should be equal to 26.7 something like that, and Vy will be equal to negative. Okay, so when you calculate the angle you may use the exact value, but I need to show you I just use the rough value. So when you have these two components of velocity, so if you draw this in a graph, what is the direction? So let's say this is a graph. Okay, so you have a positive x here, but you have a negative y. So mean this item is like this. Okay, so after 6 seconds, the item actually is moved down, right? So if you want to calculate the angle, so you should calculate the angle here, theta here. Right, so if you want to calculate this angle, you may not need to use the positive negative. You can direct use the inverse tangent 13.2 13.32 13.32 is the vertical one, y over x 36.95 something like that. Okay, so you will get the angle below the horizontal will be 26.3. So in the exam at the end it's good that you say the angle will be equal to 26.3 below the horizontal, because sometimes if you did not mention the angle we do not know, okay, the angle actually is at below where. Okay, if you just give 26.3, the examiner may not know this is below the horizontal, above the horizontal, or below the vertical. We don't know. So if you have get this 26.3, you should mention below horizontal, positive x-axis, or below anything. Okay, so you must have something description at the end, right, for the angle, so that we know this angle is calculated from which area. Okay, E. The times at which the baseball is exactly 36.75 meter above the ground. Okay, so this one easy, just put inside the Y formula. Okay, right. So above 36.75 and equal to 53.9 size 60 t minus half a t square, right? So you may simplify this okay, for this kind of question, if you cannot factorize, you must use the formula to show how you get the answer. You may use your calculator to check the answer, but you must show how, right? So if you use the calculator to get the answer for this kind of question for T, you may not get the marks in order to solve the question. So if you directly show the answer only, you may deduct marks even your answer is correct. So if you cannot factorize, you should use the b square minus 4ac, that's formula, the quadratic formula to solve it, right? So for this question, if you proceed to solve it, you will get t equal to 0.9 and 8.5 second. Okay, most probably because this is a projectile motion. Projectile motion means it's a symmetrical graph. So two sides will have the same height, right? So 0.9 will mean the first time, okay, that have a 36.75 height. Then until it reach to the maximum, then come down again. You have a second time of 8.5 second, when it has a height of 36.75 meter height. So okay, so this is the basic things that you need to use, okay, in order to solve the projectile motion equation, right? So we'll move to question 3. So before question 3, you have some question I already put below the exercise. You may proceed to solve the question in part 1. Okay, anyway, so later we will proceed to question 3, right? We stop here a while first.